Money Functions Part 2. In this section, we will be looking at end of period payments, beginning of period payments, and solving for the number of periods. Computing end of period payments. Danny plans to attend a college costing €120,000 lump sum. He plans to set aside a portion of his salary at the end of each month for the next 5 years. If the savings accounts offer interest of 8% per annum compounded monthly, how much should Danny set aside each month to achieve his goal? To begin with this question, we again gather the relevant information. $120,000 is the amount Danny needs to attend college. 8% is the rate of interest Danny can earn monthly on his investment. And the time Danny has to save up for the funds is 5 years, which we need to convert into months. We begin by clearing the calculator memory. We'll press the second, clear TBM, we'll type 5, multiply 12 for 12 months, equals, so we have a total of 60 periods or 60 months. We'll assign that to n. We will then take the rate 8, press divide, 12 for 12 months, press equal. The rate is 0.667 for each month, and we'll assign this to I by y. We'll press 0 for present value, and we'll type 120,000 and assign it to future value. We will then press CPT, compute, and PMT. The amount on your screen is $1,633. This implies that Danny needs to set aside approximately $1,633 each month for the next 60 months to be able to save up for college. What if Danny was saving money at the beginning of each month instead of at the end of each month? So let's take a look at an example where we compute begin of period payments. The example is the same as before, with the only exception that Danny is setting aside enough money at the start of each month. In order to change a calculator setting to take into account the beginning of month payments, we will have to press second, the yellow button, PMT, which stands for begin. We'll press the yellow button again, second, press the enter for set, and your calculator screen should switch from end to begin mode. To exit the application, you will then press the yellow button, second, and quit, which is CPT. Now that you have successfully changed your calculator setting to the begin mode, we will then proceed with entering the same information as before. But once again, remember to clear your calculator memory. So we start by pressing the second and clear TBN. We will type 5, multiply 12 for 12 months, press equal, you will get 60. These are the 60 months that Danny is saving for. Assign this to n. We will then type 8, which is the rate of interest, divide 12 for the 12 months, press equal. 0.667 is the rate of interest per month. Assign this to I by y. We'll then press 0 and place it into present value. We'll type 120,000 and assign it to future value. We'll then proceed to pressing compute, CPT, and PMT. This time on your screen, you should be able to see an amount of 1,622. Notice the amount is smaller than the amount we calculated in the previous example. This is because Danny is saving money at the start of each period rather than at the end of each period, thereby earning one extra period of interest by just saving at the start of the month. To exit the BGN application, you must repeat the same steps once again. You will press second, the yellow button, PMT, second, enter. You will see your screen switch from BGN back to the end mode. To exit this application, you will now press second and quit. Solving for number of periods. Let's take a look at a situation where you have been given the relevant information, but instead you were asked to solve for the n, or the number of periods. Smith has placed $50,000 in an account paying a fixed rate of interest, 4% per annum, compounded quarterly. Few years later, Smith emptied his account by withdrawing the entire balance of $95,000. How many years did it take Smith to accumulate $95,000? We again begin by gathering all the relevant information. $50,000 is the amount Smith had placed in the account at the start, so that will be our present value. His account was paying him an interest of 4% compounded quarterly. That would be our I by y, but we have to adjust it to make it for a quarter. Smith emptied his account when it was worth $95,000, and that will be our future value. We begin by clearing our calculator memory. Go ahead and press the second and clear TBM. You will then type 4 for the rate, press divide, 4 once again because there are 4 quarters in a year, press equal to sign, That's 1% of interest per quarter. Assign that to I by Y. You will then type 50,000, press the plus minus sign to the left of the equal to key, and then assign it to present value. You will press 0 and assign it to PMT. You will type 95,000 and assign it to future value. You can then press CPT compute, press the End button. On your calculator screen, you should be able to see 64.5. This means that it would take Smith 64 and a half quarters to be able to grow his money from $50,000 to $95,000. Since the question asks us how many years it took Smith to accumulate his funds, we must convert a final answer into years. So go ahead and press divide, type 4 for the number of quarters, and press equal to sign. On your calculator, you'll be able to see 16.12. This means that it took Smith 16.12 years to grow his money from $50,000 to $95,000, provided that he was earning interest 4% on an annual basis, but compounded quarterly.